Hi, everybody, and welcome to today's Torque Talk session. Thank you for taking the time to join us today. If you're not familiar and you haven't been on one of these before, welcome. For a little background, this is a monthly session we host for the Torque community to show the latest in the platform. We typically try to focus this around a specific use case. As always, these are interactive sessions, right? So we try to keep it pretty informal. We'll see a few slides to begin and set the stage a little bit. We'll spend most of the time in a demo of the product, but please submit any questions that you have through our Q&A. I'll be monitoring those on the back end here. And then at the end of today's session, we'll take some time out with our speaker to answer any questions that you have. Speaking of which, today we have our CTO, Eden Eventhal. He's going to give a presentation showing in a demo showing how to establish visibility over infrastructure as code and cloud environments through Torque. If you have any questions about Torque, Eden is the person to go to. So you're in good hands today. Now I'm going to hand it off to Eden to get started with the session.
Hi, everyone. Thanks, Colin. And we have a few slides just to put things in context and to describe the topic that we're going to present, and then demo Torque, our multi-tenant SaaS platform, and do some back and forth between the presentation and the demo, and then open it up for questions. So on the agenda today, we're going to talk about the challenges, then the Torque approach, and then dive into the demo. So the current challenge that we want to talk about today is do you really know who is using your IaC resources at any given moment? Meaning that, and we'll use Terraform as an example, but it could be OpenTofu, CloudFormation, cross-plane assets, whatever the automation assets that you might have. So when you have a Terraform file, and let's say that is, has been instantiated maybe through a command line or something like that, it could use all kinds of other Terraform modules, submodules. Do you really know who's using that submodule? Can you really responsibly make any changes to those files without understanding the impact to those changes? When you now look at a cloud resource, let's say on the AWS console, do you know if that infrastructure resource on the cloud, is that somehow tied to any IaC that it has been instantiated from? Those connections and understanding are really critical if you really want to practice platform engineering and infrastructure CI/CD in a way that can really allow you to update infrastructure and to really responsibly make changes to your automation assets. So this is the challenge that we're going to tackle today. And in general, I would say that what we help with is take organizations, and the position of each organization might be different, but to be able to take organizations from the lower left side that we call here ClickOps chaos, a lot of resources on the cloud that might not be controlled in terms of security and governance, or sometimes cost, to be able to basically curate them and provide visibility, to be able to provide a self-service approach to infrastructure on the cloud. And once the different workloads are managed, to start operating them in a way that allows data operations, and then you can get basically full control, and then obviously get all the benefits that we see here on the right side to basically take you to the upper right side that we see here. And the degrees and situations in different organizations might be different, but this is the general trajectory that we take our customers in. So in the challenge that we just presented, then our approach is, and we'll see that in the next slide, to basically introduce the environment entity to make that a first-class citizen in the platform in order to bridge between the different IaC assets that you have and basically the cloud resources. To be able to understand by that the mapping between some sort of IaC, let's say a very common Terraform module, and the environments that are now being using that Terraform file, and let's say to an S3 bucket. And to be able to basically label everything that you want in terms of that environment in order to really get quick access to whatever you need in terms of your infrastructure. It really helps once you have that managed environment, because then you can basically detect idle resources, and then to be able to really provide that higher level of optimization on top of your cloud resources. And all of this is also encompassed in this slide here, where in the middle, we see that environment entity. And everybody is talking about how can we automate as much as possible using GitOps approaches, basically everything, or as much as possible as code. And then you see on the left side, the ability to really gain all the benefits of having something consistent and something that would be easy, reproduced easily, to be able to provide a self-service approach and to really drive infrastructure CI/CD. And once that is done, then the different services that we can provide on top of an environment are listed here on the right side. I'll maybe just briefly touch the ability to really provide drift, to push updates that we'll see in a second, to really apply tags and to have a tagging strategy in the organization that is mostly seamless to the end users and happens by definition. To be able to drive data operations, because everything that we see here in terms of the environment is stateful. It's not a fire and forget process. It's something that has that context and basically has the ability to perform any data operation, starting from health checks to all kinds of optimization automation processes like turning off a virtual machine or deleting an RDS instance, and whatever is needed in terms of making the consumption of cloud much more efficient. So once we clarified a little bit about the environment entity, then in the context of this webinar, what we would like to show is, and if we look at it from left to right, is the ability of looking at the Git repository. And a lot of organizations and DevOps teams have this Git repository with different IaC assets in them, and basically understand the mapping between the different assets to what you see on the right side, the cloud and instances on the cloud. And we do it in a form of a managed environment that has all the tags applied to them, that basically once you have this managed environment, then our cloud Copilot engine can start detecting idle resources. We can then say that, if this environment hasn't been accessed for a certain duration or a certain period of time, then you can take action. And also you can apply and paint the environment in all kinds of colors that help you identify it much more easily and make sense of all the cloud resources. So this is sort of a diagram that will help us in this demo. And with that, let's dive into the demo. So I'll keep this slide in the background and move into Torque itself. So, and we can just start by saying that, this is Torque. This is our Quali account that helps us with demos and demonstrating the platform. We see here the self-service catalog, just a sample catalog of all kinds of what we call blueprints, templates of environments that we can launch. If we look at it from a situation where someone already has all kinds of IaC assets, then we would usually go into the repositories section and add a repository, and all the common Git repositories are supported, whether public cloud offerings or the self-managed repositories. And once a repository is defined, then we start scanning for the different technologies, different automation assets that we can see here. If I go into this repository and view the assets, then this will look very familiar to me, because this should be the representation of the Git assets that, if I would go into GitHub, I would see. But I also get the Torque perspective, and I can start labeling these assets. I can start making them blueprints, or just, start launching them from a central location in order for this to be much more scalable. And in the context of the topic of the webinar, we would like also to start seeing the IaC mapping of certain IaC assets. And in the case of this KMS key, then we can go and see the impact mapping, and we can start seeing all the connections of this Terraform asset and see the, who is using this KMS key, because this KMS key is something modular that is being used by others in probably several places and locations. Also, very important is to see actual live environments that now are using this asset, which means that now when I make changes, I know on which environment this will affect. So, and everything, we talked about GitOps in a brief. So this, everything has, commits to it and all the best practices in order to work very nicely in a GitOps approach. If I go and see an asset that has more references, then I can see that, this Lambda function Terraform asset has several environments that are now up and running. This makes the update of this asset and understanding the effect of it on actual live environments much more easily, and I can now make easier way. So with that, I'll move to basically the managed environments. And everything that we saw here can be also seen in our operation hub, where we can see, in this case, all the active environments. It's possible also to see all the history and all the cloud resources that were instantiated throughout the history of the certain cloud accounts. We can see in this case where I have certain notifications that there are certain updates that have been made to a certain asset. And now these changes, I can look at them, understand what's going to be updated, and basically push the update. From the other side, you can also see drift notifications, meaning something is inconsistent with the cloud state and the actual known state to Torque. And basically, this really helps us in terms of the flow that we saw from the understanding of the effect on live environments and pushing the updates themselves to the environments once you feel comfortable updating certain environments. And if I go another perspective,
and I'll just choose another example, another environment, then you can see basically all the tags that you see here were actually automatically pushed into these cloud resources. And you can see a complete list of all the resources that were instantiated right here. And everything that we can tag, we tag automatically, plus the option for customers to define their own custom tags and basically apply them as well. And we also have logical labels on the environment, because sometimes customers of ours manage the environments here and want to give them some sort of color in the form of a label because it's in a different life cycle, in a dev, test, staging, or production. Or sometimes it's a certain application. In this case, I added a label of a team. So I would like to basically say that I want all the Raptors team environments. So it gives you the ability to manage things in a much easier way and to be able to really manage the context of large scale environments in a much easier way. So we talked about the managed environment. We talked about the labels that we can apply, the tags that can be applied. And maybe before idle detection, we'll talk about user access. We can see that there is this column here that we basically Torque manages and allows to basically see when was the last access to the environment. This is something that is calculated on an ongoing basis and can be used in order to drive automation, in order for customers to apply all kinds of shutdown or pause of certain resources if an environment hasn't been accessed for a certain duration. So let's say I would like after 1 week to pause all resources that are possible. And after another additional week, if that doesn't happen, if the inactivity continues, to be able to shut down the environment. All these, this sort of logic that I just defined can easily be implemented because we are managing the last access. So this is something that can be really helpful in order to drive efficiency. And maybe tied to that are is the ability and the option to identify idle resources. So another great service that comes with Torque is once an environment has been instantiated and this list of resources is now part of the managed resources in Torque, then we start looking for tracking inactivity with our Copilot AI engine. And once we identify potential savings, then we notify about this. And then we start providing this information in reports. And this can come in the form of opportunity savings, meaning we identify certain resources that if you apply some sort of automation to it, you can save, in this case, not too much, but nonetheless, this is something that if you look after, we have situations in some of our customers that it's super dramatic, the amount of workloads on the non-production accounts that can be saved once you have clarity to potential savings. And another important aspect is once you apply it, then we can also tell you what is the realized cost saving. And everything goes down to the granularity of the environment and the actual resource. So in addition to the high-level graphs over time and to the numbers, it can really go to the granularity of each resource. Sometimes it's required if something goes wild in a very clear situation, then you can basically drill into whatever is needed in order to debug and take action in a certain situation. So if I go back to this diagram, then starting from the IaC assets that we saw, moving to basically the concept of a managed environment that we saw, and how can we apply labels, how tags are being applied, then the user access, the last access, and then the idle detection. All this can brings clarity into the usage and the mapping between the different IaC assets and the cloud resources. So with that, I think we'll move to any questions that.
All right. Yep. Thank you, Eden. And we have a couple questions that came throughout this session. As a reminder, we're still open for questions. So if anyone on the line has anything else they'd like to know, please feel free to submit them through the Q&A. The first question came up about midway through your demo and asked, is this only for new workloads? What if I have existing cloud workloads?
Okay, cool. So it's important to mention that Torque can, as we presented at the beginning, can hook up to your repositories, identify the automation assets, and basically you can start launching environments from them. But it's also possible to hook up to existing Terraform state files, or even connecting to a certain cloud account, and basically looking at all your cloud resources. One sec, I want to show an example. And basically, even if it's resources that are unmanaged, okay, we call it according to, we classify resources on the cloud according to their IaC status. Unmanaged, meaning created through ClickOps. Codified, meaning it could have been created through a form of automation, launched through OpenTofu, Terraform, but we identify a pattern that it was done through automation, or managed, created through Torque. And we provide a way for customers to basically identify the collections of certain resources, to curate them, and basically codify them into Terraform, and then create the automation from it. So it's definitely not critical in certain cases to start and create environments from your IaC assets. Existing workloads are definitely something that we know to subsume. And then once you have a managed environment in Torque, start benefiting from everything we showed.
Thank you, Eden. We have one more question here, unless anybody comes through with anything else. This came through when you were showing the inactivity detection. We had a question asking, how is cost calculated?
Okay. So Torque, and we have here a section in our public documentation that talks about reports and how we basically present the cloud efficiency reports. We track for actual cost on the different cloud accounts, subscriptions that the customer has. And then we are able, by that, to break it down into the cost of certain resources, and from there to be able to determine the potential savings. So once the algorithm reaches a situation that we score the, let's say, the idleness probability, once that threshold reaches a certain number, then we are able to notify not just that there is a high probability for idle resources, but we are all able also to associate a cost for not taking action on those resources, and therefore provide the potential saving number.
Okay, it looks like that's all we have for this week. Thank you to our audience for taking time out of their day to join the session. Thank you, Eden, for your time. This was a great demo. Really appreciate it. And as always, thank you to Corey on the back end for making sure everything worked correctly. You can learn more at quali.com. And if you want to get hands-on with the product from quali.com, you can visit the Torque Playground. That's a fully publicly available version of our software. You can go and launch actual cloud infrastructure, actual environments from the playground, and that's accessible once again at quali.com. Thanks everybody, and we'll see you again next month.
Thanks.